Hello everyone, I am Kaushik Shankarar and this is 29/7/2024 and this video is about the demonstration of experiment 2 in the electronics lab course. This experiment is about Wheatstone bridge with a low pass filter. This experiment is about to construct a Wheatstone bridge using resistors, calculate and measure the node voltages and its output voltage. Additionally, this experiment is to investigate the effect of adding a capacitor across the output to filter unwanted AC components. Let us see the materials required. We require 400 kilo ohm resistor, two 1 kilo ohm resistor, two 10 kilo ohm resistor, a capacitor, a multimeter and an analog board, which is ADALM kit given. The capacitor which we are going to use is 103, which is 10 nanofarad in capacity. As I am not having the multimeter to measure the capacitance, I am just going to take it as 10 nanofarad. Now I am going to measure the resistance of each resistor and note it down in this note. I have measured all the values using the multimeter. Let us move to the part 1 of the experiment. In this experiment, we are going to build a Wheatstone bridge with 400 kilo ohm resistors as shown in this circuit. I am going to build this circuit. Let's move into the measurement and calculation part. The node A voltage can be calculated with the formula shown here. Similarly, the node B voltage. This is the concept of voltage divider, and the output voltage can be calculated by subtracting the two node voltages. This is the calculated voltage of node A and node B. This is the calculated voltage of the output. This is the voltage of node A measured in millivolts. This is the voltage of node B measured in millivolts. This is the voltage of output measured in millivolts. Let us give a sine voltage as excitation and measure the values for node A and B. Now the channel A is connected to the input and I am going to give a sine wave with 1.5 volts as the minimum and 3.5 volts as the maximum, as this would give the sine wave 2.5 plus 1 sine omega t. You can see that the measured DC voltage across the two is more or less equal to 0 volts. This shows that the Wheatstone bridge we have built is balanced. Now I am going to build a balanced bridge if the components available are 1 kilo ohm, 100 kilo ohm and two 10 kilo ohm resistors. To build a balanced Wheatstone bridge, it has to satisfy the condition R1 by R2 equal to R3 by R4. This is the circuit I have built with these given components to have a balanced Wheatstone bridge. Now I am going to build this circuit and show whether it is balanced or not. I have built the circuit and you can see that still the voltage across the output is 0. So this bridge is balanced. This is the node A voltage and this is the node B voltage. Now let us go to the part 2 of this experiment, Wheatstone bridge not in a balanced condition. This experiment will show that even a small change in the resistance can lead to change in the output voltage. I have finished the circuit and I am going to give the input. You can see as the circuit is not balanced, there is a slightly increased voltage, though it is in millivolts because the 1 kilo ohm resistor is much smaller than 100 kilo ohm resistor. This is the output voltage. This is the voltage of node A in millivolts. This is the voltage of node B in millivolts. Let us go to the part 3 of the video, low pass filtering. This is the circuit which is very similar to the circuit we have used in part 2, but a 10 nanofarad capacitor is connected across AB. Let's build the circuit. You can see the output voltage in the multimeter, which is similar to the output voltage we got in the part 2 because the capacitor doesn't allow any DC voltage to pass through it. The ADLM kit can't measure the voltage across A and B because it only has one ground. Rather, the traditional oscilloscopes have two separate grounds. So, it can do only any one thing. If it is giving the input, it can't measure the output. So, I am directly going to calculate the corner frequency using this formula. By disconnecting the power source, I am going to measure the equivalent resistance of this circuit. You can see in the multimeter the equivalent resistance of the circuit is around 97.5 kilo ohm. The corner frequency is coming around 163.24 Hz. Next, I am going to build a Thevenin equivalent circuit across the nodes A and B and having the capacitor as the load. As the equivalent resistance is 97.5 as measured before, the Thevenin resistance is also 97.5. I am going to build the Thevenin equivalent circuit. This is the Thevenin equivalent circuit I have built with a 10 kilo ohm resistor series with 10 nanofarad capacitor as the load. I have connected channel A to the input and channel B as the output voltage across the capacitor. I am going to start measuring the output voltage for each of these frequencies written in the note. These frequencies are in hertz. I am going to measure the peak to peak voltage. While seeing the measured values, we can see that the graph started to decline at about 150 to 200 Hz. So I guess that the corner frequency lies between 150 to 200, which is very similar to the corner frequency we got as 163 Hz, which is also lies between 150 and 200 Hz. This is the graph plotted with the measured values. The results may vary from the theory because the components can have different values not equal to the value mentioned. This is because no component can be manufactured perfectly. As mentioned, the ADLM kit cannot measure while giving input. Done this experiment like a low pass filter experiment done in ESTC lab.